Okay, tonight we're going to look at the theorem that's talking about the relationship between chords or congruent chords and their intercepted arcs. And if we read the theorem, it says in the same circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So we're talking about the chords, the arcs being congruent if the chords are congruent. So notice I have chord AB congruent to chord BC. So that would tell me that the arc formed by both of those chords, the arc formed by chord AB would be arc AB, would be congruent to the arc formed by chord BC, which would be arc BC. So those arcs must be congruent if they have congruent corresponding chords. So we want to answer questions here. This question wants us to find segment AB. So if I look in the picture, segment AB is going to go from A to B. I want to find out what it equals. Well, I know arc AB equals 155. And I know arc DC equals 155. So I have congruent arcs. So if I have congruent arcs, then the chords must also be congruent. So if chord DC equals 9, chord AB also equals 9. Number 2 wants me to find chord FG. Chord FG goes from F to G. I can tell by the symbols that FG forms arc FG, which has the congruent mark here. I can tell that chord EG forms arc EG, which is also congruent to FG. If EG is equal to 6, what would be the length of FG? It would also have to be 6, because if you have congruent arcs, then the corresponding chords are also congruent. This one wants me to find Km, so I go from K to M. Alright, I can tell here that Km makes the arc Km. And I know that here I have measurements on JL, and it forms arc JL. Well, I know that this part of arc KM is equal to this part of arc LM, and this part in the middle is in both of them, so by the reflexive property it's going to be congruent to itself. So the distance from J to L would have to be 5 plus 3, which would equal 8. So that would make the distance from K to M also have to equal 8. This question wants me to find the measure of arc, there's your arc symbol, XY. So I'll go around the circle from X to Y. Now I know that segment XY is going to be congruent to segment WZ because they have the congruent marks. I know that arc WZ equals 105. So that makes arc XY also have to equal 105, because corresponding arcs of congruent corresponding chords are congruent. This question wants me to find the measure, M stands for measure, of arc TU. This is what I'm looking for. I know that I have congruent chords, are SR and TU. So I know that arc TU must be congruent to arc SR. Now I'm going back with my central angles. I know that central angle SQR is equal to 85. That would mean that the arc formed by that angle would also have to equal 85. That's what we worked on in class today. So that would make the measure of arc TU also equal 85. Number 6, and the last one we're going to do tonight, wants us to find the measure. M stands for measure of arc AB. So we're looking from the distance from A to B. I can tell by the picture that chord AB is congruent to chord AC. So I know that arc AB must be congruent to arc AC. The only problem is I don't know what arc AC equals. But I do know that a whole circle has how many degrees? It has 360 degrees. And I know that I know that 100, that's the arc we know, plus the two arcs that we don't know, but we do know they're congruent, equals a total of 360 degrees. So that would give me 2x when I combine my like terms, plus 100 would have to equal 360 degrees. So to solve it, I have to work a two-step equation. I need to subtract 100 from both sides. So that's going to give me 2x equals 260 degrees. And to solve from there, I need to divide both sides by 2 to isolate the x. So x has to equal 130 degrees. So both of these arcs have to equal 130 degrees. And I could check that by adding 100 plus 130 plus 130. And it should give me a total of 360. Which it does. Because all circles have a total of 360 degrees.